Hi friends, welcome to our channel. Let's look at this problem. Find the minimum amount of time to brew potions. This problem actually is marked as medium, but the understanding of the problem statement indeed requires some time. So here I'm not going to go through the problem statement, but I'm going to point out the main observations. And the solution to this problem basically is just the iteration, right? So basically we are given two integer arrays. One is called scale and one is called manner of length n and m respectively. So we want to return the minimum amount of time required for the potions to be brewed properly. So this is at the problem constraint. So there are two constraints. So one is no wait and the other is order requirement. The no wait requirement is the following. If a wizard I finishes a portion, say at time Tij, then the next wizard I plus 1 can immediately start for that portion. That is, the start time of wizard I plus 1 is the finish time for the previous wizard. So this is the observation 1. The second observation is the following. So we need to have order requirement. So for wizard I, so portion j plus 1 can start, right, from portion j. It's only after portion j is completed. In other words, the start time of wizard I for portion j plus 1 will be greater than or equal to the finish time for this wizard with respect to portion j. So once you realize these two key points, I guess doing the coding should be very straightforward. So here there's three examples. I'm going to analyze example 1 because they also list some tables to help us understand the logic. So first, for portion 0, for sure, the wizard 0 should start at time 0, right? So the finish time for this wizard is this 5, 30, 40, and 60, right? So you can use 1 times 5, so you get 5, right? Then 5 times 5 will be 25. So accumulate 5 plus 25 will be 30. And then the wizard with skill 2 times 5 will be 10. 10 added to 30 will be 40, right? And then you have 4 times 5 and then added to 40 will be 60, right? So this list is the finish times for portion 0 for all the wizards. Then so we are going to find the earliest time for portion 1, the wizard 0 can start, right? Assume that the start time is t, right? And then the finish time of portions will be the following. So in order to finish this, for the first wizard to finish, we have 1 times this 1. So that's the t plus 1 times 1. And then we will accumulate. So the second wizard will have 5 times 1. So, you know, from this previous one, we add this 5 times 1. So similarly, we would added 2 times 1 here, right? And then from the previous one, we're going to add 4 times 1. So this will be the finish times. So you can do some simplifications, right? So essentially 1, 6, 8, and 10 are accumulated finish times. So if you add t, those will be the exact finish times. So observation 1 actually is automatically embodied by the sequence fashion when we compute the finish time, right? So the requirement with respect to observation 2 is the following. So when I finish the first one, I shift to the next wizard. So the previous finish time should be this time t plus 1 should be larger than or equal to the previous time. This is 30, right? Shifted. So t plus 1 should be greater than or equal to 30. And t plus 6 should be greater than or equal to 40. Similarly, t plus 8 should be greater than or equal to 60. So we need these three relations hold simultaneously, right? So you see t should be greater than or equal to 29, 34, and 52. So we need to take the maximum. So that is 52. Later you will realize we just need to, translate this analysis into code. So with this done, so we know that we can the start time for without 0 for portion 1 will be t equals 52, and then you can substitute the t into this list to get the finish times. So this is nothing but this line, 53, 58, and 60 and 64, right? Then you do the same thing for portion 2, and you find the start time for without 0, and then you continue. So finally, we just need to return the last time point for portion n-1. So this is the one we are going to return. So this is the logic of this problem. So now let's look at the coding. So this coding part, you can choose to write it very short or with certain redundancy. So here I'm going to write with some redundancy for the purpose of understanding. So first I'm going to initialize start time to be 0. And then we have a previous finish times, right? So we are going to compute those things. So I'm going to first compute for mina 0 or portion 0, right? So current start, so it'll be 0. Then let's first get the for portion 0. So for s in scale, then the current, this is actually the start time, right? So then plus the time needed to finish, that is s times mina 0, right? And then we are going to do append operation, right? So by now, if you print out this previous, you are going to get this this line here. Let me run it. Yeah, you are going to get 5, 30, 40, 60, right? So now let's continue this procedure. So once we have this, then we are going to iterate, right, for I in range, so from 1 to the length of the mina. So then we can compute the finish time for the current mina or portion. So let's see, current will be empty list, and then current start are also set to be 0. Actually, we need to shift it using t here, right? But let's first compute 1, 6, 8, and 10. So what we do is this. For s in scale, current start will incremented by s times mina I, right? Then current will be append this current s. So now we can update the start. So we want to compute the t. So in other words, t is the maximum of 30 minus 1, 40 minus 6, and 60 minus 8, right? So what we do is this. So we can initialize a start. So we can see next start. So we can set it to be previous say 0, right? And then you can set it to be 0 or anything small enough. So then what we do is for j in range, so 1, the length of previous, right? Then what we want to do is the next start will be the maximum of its previous state, and then the previous j, right, corresponding to the finish time before, right, like this 30, 40, and 60, and then minus this 1, 30 will minus 1, 40 will minus 6, and 60 will minus 8. So it will be this minus current j minus 1. So notice that we start from 1 for j. So j minus 1 is greater than or equal to 0. So once we have this, so we get the correct start time for the current portion. This start time will for without 0. So now let's update the time. So in other words, we want to compute substitute t into this one to get this one. So basically, what you do is, so for k in range length previous. So what I'm going to do is I'll just replace the previous to be the current time plus the next start, right? So this actually plays two roles. First, we computed this time, and then we update the previous to be the current, and then we go to next round, right? So now what we want to return actually is nothing but previous -1. So this will be the full code for this problem. So now let's do a test. Yeah, it passes the 3 test cases. Now let's look at generic case. It takes some time for running for this problem. Yeah, it passes all the cases. I guess with this done, that's basically about it for the current problem. I guess there are 2 comments. One comment is that it's important to notice the problem type and correspondingly the key requirements or observations. So this is the one. Another one is that when you compute this one, so these are 3 inequalities. You get the next earliest starting time. So then you translate in this part into this loop with maximum, right? Then the start, you can choose it, choose a smaller one, but you can not choose too much, but too large a start value, right? So this is the second comment. With that said, I guess that's it for the current problem. Thank you for watching.